Hello, class 12 students. Welcome once again to Math is Possible. Today I am going to do the second part of the chapter Continuity and Differentiability. I will start with the questions now. In the previous video I explained about what is continuity. Okay. Now we are going to do a few questions. We are going to start with a few questions and then we'll continue. Okay, with this continuity part. Okay. So the first question, the exercise is given as exercise 5.1. Many exercises in this chapter, continuity and differentiability. So we start with exercise 5.1. We'll go to 2, 3, 4, 5, 6, 7, 8, 9, 10. Exercise 5.1, 5.2, 5.3, 5.4 like that. Okay, many are there. So let's start with the first one. It's saying that examine if the given functions, okay, if the functions, examine if the functions are continuous, okay, continuous at the indicated points, at the indicated, okay, at the indicated points, at the indicated points. So we have to check whether the given functions are continuous at the points that they are talking about. So this question has two parts. First part, f of x is given as x cube plus 3 when x is not equal to 3, and it's going to be 1 when x is equal to 3, or what is it given? 0, sorry. When x is not equal to 0 and equal to 0, it's going to give you the answer as 1. We have to check whether the function is continuous at x equal to 0. So you have to check whether this function is continuous at x equal to 0. Now all of you all know this, how to check. Where is the red marker? Somewhere around here. Okay, let it be. Here, this is what you have to prove. Limit of x tends to c negative, f of x has to be equal to limit of x tends to c positive, f of x has to be equal to the function f of c. Okay, so what does this mean? This is how you have to prove continuity. This means that approaching c from the negative side, this is approaching c from the positive side, the graph. Okay, and this you just have to put the value f of c and check they are equal. This is equal to the function. So let's start. Write LHL, that is called the left hand limit. So write limit of x tends to, okay, x tends to 0 negative, f of x is equal to limit of x tends to 0 negative. Okay, now which value are you going to take? Are you going to take 1? No, you are not going to take 1 because this is not equal to 0. Okay, this x is approaching 0, going towards 0, but it's not equal to 0. So you see, when you make the graph, no, so the graph is approaching 0, okay, from this side, but didn't reach 0 as yet. So if it's not equal to 0, it didn't reach 0 means it's not equal to 0. So we'll use this part. So write x cube plus 3 is equal to what? Put the 0 now. You have to put the 0 as a value. So 0 plus 3 is just 3. Next is the right hand limit, RHL. Okay, that is limit of x tends to 0 positive, approaching from the right hand side, limit of x tends to 0 positive. Now put 0. Now what function are you going to use? Again the same thing. Why? Because it is approaching 0 from the right hand side but didn't touch it. So now when you put 0 over here, what are you getting? You are getting 3. But when you do f of 0, what are you getting? As you put 0 in the function, you are supposed to get a 1. So these two are equal to each other, but it's not equal to the function. So the function is not continuous. It's discontinuous. So you write limit of x tends to 0 positive, f of x is equal to limit of x tends to 0 negative f of x, but is not equal to f of 0. Both these things are not equal to f of 0. So f is discontinuous. F is discontinuous. Now let me check the answer for you. The answer page is actually, the red marker is there. Now I found it. Okay, it's saying discontinuous. Okay, part 1 is discontinuous. So actually this is what I wanted to do. I wanted to mark this as a box. Every time you have to use this. Okay, this is your basic continuous thing. Okay, this is what you have to use every time to prove that a function is continuous or not. Okay, let's go on to part 2 and check if the function is continuous. Okay, part 2, question number 1, part 2. Okay, so part 2 is given as this. F of x is given as x cube plus 2x square minus 1. X cube plus 2x square minus 1, and you have to check whether the function is at x equal to, you have to check whether this function is continuous at x equal to 1. So let's start LHL. Okay, what do you have to prove? Simple. Limit of x tends to c negative f of x is equal to limit of x tends to c positive f of x is equal to f of c. When you can prove this, then it's correct. So let's start LHL. This is the left hand limit, that is limit of x tends to 0 negative f of x approaching from the negative side, limit of not 0, it's given as 1, my mistake. 1 x tends to 1 negative f of x is, what is it, x cube plus 2x square minus 1. So put the value as 1 over here. So 1 cube is 1 only, 2, 1 square is 1, that's 1. So 1 plus 2 minus 1, which is equal to 2 plus 1, 3. Okay, you can also do the opposite way. 2 minus 1 is just 2 and 1 plus 1 is 2. So that's what you will get. Now RHL, right hand limit, is limit of x tends to 1 positive f of x is equal to limit of x tends to 1 positive. Okay, that is x cube plus 2x square minus 1 will again give you 2 because you put 1 over there. You won't put minus 1. Okay, don't put minus 1. Now after this, simple, f of 1 you have to find. F of 1, put 1 over there. 1 plus 2 minus 1 is again 2. See, all three of them are equal to each other. Now you write, so limit of x tends to 1 negative f of x is equal to limit of x tends to 1 positive f of x is equal to f of 1, which is equal to 2. All of them are equal to each other. So what happens? So f is continuous. N-U-O-U-S. F is continuous. Now let me just check the answer for you. Yes, it is continuous. Of course, you can see from the board only. Yes, it's continuous. Okay, let's go on to question number 2. Alright. Let's go ahead and do question number 2. Again, question number 2 also is another easy question. Okay, question number 2 is saying, prove that the function this is continuous at the indicated points. So question number 2 is already saying that prove that it is continuous. So nothing to worry about because it will continuous. It will come continuous if it's telling you to prove that it is continuous. So the points that are given are x equal to 0, x equal to 1, not x equal to 1, x equal to minus 3, x equal to minus 3 and x equal to 5. These are the 3 points. You have to check whether the function is continuous at these 3 points. So let's start with the first one, that is x equal to 0. So start with LHL, left hand limit. Okay, is what? Limit of x tends to 0 negative f of x is equal to limit of x tends to 0 negative, what is that? That is 5x minus 3. Now you put 0 over there, so you get minus 3. Okay, limit of x tends to 0 negative f of x is going to give you minus 3. Then RHL, right hand limit, let's write down. Right hand limit RHL Okay, so that is limit of x tends to 0 positive approaching from the positive side, that means equals to limit of x tends to 0 positive, that is 5x minus 3, that will again give you minus 3. That's it. Now what is the next part? F of 0. So f of 0 is also equal to minus 3. Put 0 over here, you will get minus 3. So limit of x tends to 0 positive, f of x is equal to limit of x tends to 0 negative, anything you can write first, is equal to f of 0, which is equal to minus 3. So the function is continuous. So here I am just writing yes, but you write yes, the function is continuous at x equal to 0. Okay, I will write yes, no, you will write the whole thing. Okay, second part, x equal to minus 3. Wanted to do this because this is the main thing that you will understand from here. Okay, what I am saying, approaching and minus 3 thing. So LHL, the left hand limit of x tends to minus 3 approaching from the left hand side. Understood? This minus 3 is minus 3 only, and that power is approaching from the left hand side, is equal to limit of x tends to minus 3 approaching from the left hand side. So minus 3, that is 5x minus 3. When you put minus 3 over there, what happens? Minus 15, 15, 16, 17, 18. That is minus 18. Okay. Limit of x tends to 3 negative f of x. Okay. The next part is RHL. That will be limit of x tends to minus 3 from the positive, approaching from the positive side. Write it properly. Minus 3 approaching from the positive side, f of x is equal to limit of x tends to minus 3 approaching from the positive side is 5 of x minus 3. Now you all might be saying that I said don't put minus 3, but it is minus 3. Okay, it is minus 3. It's not 3. It's approaching minus 3 from the left hand side, and it's approaching minus 3 from the right hand side. So you have to put minus 3 when minus 3 is given. So put minus 3, again you're going to get what? You're going to get minus 18. Next, f of minus 3, if you put minus 3 over here, then again you're going to get minus 18. So limit of x tends to minus 3 plus f of x is equal to limit of x tends to minus 3 minus f of x is equal to minus f of minus 3, which is equal to minus 18. So 2 parts are done. 5th part I leave for you. You can check whether the function is continuous. So you can see this is minus 18, this is minus 18, and this is minus 18. So yes, it's continuous at x equal to minus 3. The function is continuous at x equal to minus 3. See, minus 18 here, again minus 18 here, and minus 18 here. So these are the 3 things you will check, and you will say yes, that's continuous. Let's go on. Question number 3. Okay. Next question is question number 3. Question number 3, part 1. Both parts are do. 3 part 1 and 2 are there. Let's start with 3 part 1. So 3 part 1, what is it saying? It's saying that if there is a function given, if f of x is given as x square minus 1 divided by x minus 1, x square minus 1 divided by x minus 1, if I have a function, then for x not equal to 1, of course x cannot be equal to 1, and it's also given and f of x is equal to 2, it's also given that f of x equal to 2 when x is equal to 1. So when x is equal to 1, then f of x is 2. Then show that the function is continuous at x equal to 1. So at x equal to 1, we have to check the continuity for this function. So let's start. LHL, left hand limit, is what? Limit of x tends to 1 negative, f of x is equal to limit of x tends to 1 negative. Okay. 1 negative. So what do? Take that, write it x square minus 1 by x minus 1. Okay, you cannot put 1 now. So after this, what do you have to do? Limit of x tends to 1 negative. What do? You write this x plus 1 and x minus 1. X square minus 1 square. A square minus b square formula. A plus b, a minus b. Whole thing divided by x minus 1. X minus 1 is gone away. So limit of x tends to 1 negative. X plus 1 is left. So put a 1 over there. You're going to get 2. So limit of x tends to 1 negative, f of x is given as 2. Let's go on to the right hand limit. Okay, RHL. Now you don't have to work out the whole thing. You already got this x plus 1. So you write limit of x tends to 1 positive, f of x is equal to limit of x tends to 1 positive, x plus 1, which is equal to 2 when you put 1. So that is limit of x tends to 1 positive, f of x is equal to 2. Now when you put f of 1 over here, it's already given. F of x is 2 when x is equal to 1. When you put 1 over here, your answer is supposed to come 2. It's already given in the question. So now you can see from all three parts, these three parts are equal to each other, right? This is equal to this is equal to this. All of them are coming equal to 2. So then what do you write? Simple. Your work is over. Limit of x tends to 0 negative, not 0, 1 negative, f of x is equals to limit of x tends to 1 positive, f of x is equal to f of 1, which is equal to 2. So the function is continuous. Yes, it is continuous. Are they saying prove it? Show that the function is continuous. Okay, I showed it to you that the function is continuous at x equal to 1. So this is done. Let's do part 2 of this, 3 part 2. Okay, question number 3 part 2. It's written very short question, not short, actually short only. The questions are a little bit longer than this also. So let's go on to question number 3 part 2. So in 3 part 2, this is what you have to do. The function is given to you as f of x is equal to x square minus x minus 6. X square minus x minus 6. Whole thing divided by x minus 3. X minus 3 when x is not equal to 3, and it's going to give you the answer as 5 when x is equal to 3. Okay, now look very carefully. We have to check the function is continuous at x equal to 3 or not. Okay, so let's start. Okay, first one is what? LHL, left hand limit. So start it. Limit of x tends to 3 negative. 3 you have to check. So f of x, which is limit of x tends to 3 negative. Now which one are you going to? You're going to write 5? No. 3 negative means approaching 3 from the left hand side. That means it's not equal to 3. So we have to take that whole function. X square minus x minus 6 whole thing divided by x minus 3. Now don't go ahead and put 3, because every time you put 3 in this function, you're not going to get the answer. You're going to get it as discontinuous. So let's split this quadratic equation. You all know it. What to do? X minus 3, that is 6. HCF of 6 is 2 and 3. So those are the factors. Minus 2x plus 3x minus 6. There was a minus sign outside, that's why I split it. Okay, and put a positive sign. That's why I put a positive sign. I mean, you all are in class 12. You all know what to do. Limit of x tends to 3 negative. From here, x common, x minus 2 plus 3 common and x minus 2. Okay, plus 3 common, x minus 2. What went wrong? 3 minus 1. Okay, we cannot split it with 3 and 1 because this is not coming. This is not coming minus 1. How did I split that? Wrong splitting. Don't split. Wait. It will be 6, 2, 3s are, yes, 3, 1s are. So if 3 minus 2. So x square minus 3x plus 2x minus 6. There you go. It's okay now. Now x minus 3 plus 2 x minus 3 divided by x minus 3. Okay. So now from here, if you cancel out x minus 3, you're just left with x plus 2 on top. Okay. Limit of x tends to 3 negative x plus 2. Okay. So now put 3, that becomes 5. So limit of x tends to 3 negative f of x is going to give you the answer as 5. Let's go on to the next one. This one is now easy. It has become easy because one part only you have finished it. You have split it up. Now you know what you have to write it as. Okay. So limit of x tends to 3 positive approaching from the positive side is equal to limit of x tends to 3 positive. Will you write the whole function? No. Now you will write x plus 3 because that has reduced to x plus 2, not 3. 2. So now you put 3, then you get a 5. So only once you have to do the work, okay? The other things are just copy. That's it. And f of 3 is what? When you put f of 3, it's already given in the function. It's going to give you the answer as 5. So can you see? All three parts are equal to each other. So now you can write the function is continuous because limit of x tends to 3 negative f of x is equal to limit of x tends to 3 positive f of x is equal to f of 3, which is equal to 5. They are all equal to each other. So yes, the function is continuous. The function is continuous. They are telling you to show. You have shown it that the function is continuous. Let's go on to question number 4 and finish it off for today. Last question for today is question number 4. Okay. And then we will carry on in the next videos. Let's go on to question number 4. Question number 4, this is what the function is given as. It's given as f of x. The function is defined as this way. F of x is going to be x when x is, what is that? When x is less than or equal to 1. When x is less than or equal to 1, you have to use the value 5x, and when x is greater than 1, you have to use the value 5. And there are 3 parts to this question. 4 has 3 parts. 1, you have to check if it's continuous at x equal to 0. Second, you have to check x equal to 1. And then you have to check third is x equal to 2 or not. At which point it's continuous. Okay. That's what we have to check. Is the function continuous? Yes, that's what they are asking you. Is the function continuous? In the first one, x equal to 0. Second one, x equal to 2. So let's check. First one, x equal to 0. Okay. So left hand limit, what will be the left hand limit? Limit of x tends to 0 negative f of x is equal to limit of x tends to 0 negative. Now it's time to put the function. Which function are you going to put? See, x is less than 1. Less than 1 means what? 0. 0 is less than 1. See, 0 is here, 1 is here. Right? 0 is less than 1. Right? So you have to use that function x. So when you put 0 in x, you get a 0. Now right hand limit. Right hand limit. Approaching 0 from the left hand side. Next, approaching 0 from the right hand side. So f of x is equal to limit of x tends to 0 positive. So which one you are going to use? This is not greater than 0. Okay. This is approaching 0 from the right hand side. Probably the graph is somewhere over here. Of course, if that's less than 1. Okay. So less than 1 means again x. So x, that is also 0. Okay. Now f of 0. So f of 0 is less than 1. Again you will use this function, that is x, which is 0. So you can check that the function is continuous at x equal to 0. So limit of x tends to 0 minus f of x is equal to limit of x tends to 0 plus f of x is equal to f of 0, which is equal to 0. So yes, the function is continuous at x equal to 0. Let me check the answer for part 1. Question number 4, part 1. Yes, it is continuous at x equal to 0. Let's check the second one, whether it's continuous at x equal to 1 or not. Okay, so x equal to 1. All right, x equal to 1, again LHL, left hand limit. So that is limit of x tends to 1 negative f of x is equal to limit of x tends to 1 negative. Now less than 1, look, of course, approaching 1 from the left hand side. So what is it? Less than 1, approaching 1 from the left hand side. See, this is 1, no? Approaching 1 from the left hand side. Somewhere over here, of course, less than 1. Then you use x. Then what are you getting? When you use x, put 1 over here, so you are getting 1. Now RHL. Look at it. RHL. Limit of x tends to 1 positive. F of x is equal to limit of x tends to 1 positive. Now see. Now it's approaching 1. This is 0. Approaching 1 from the positive side. So must be somewhere over here. So that's greater than 1. So when it's greater than 1, the answer is supposed to be 5, which is equal to 5. Okay. So you cannot put any value over here. So that will be 5. So you can see LHL is equal to not equal to RHL. That's it. That's your breaking point. Stop there. So limit of x tends to 1 negative f of x is not equal to limit of x tends to 1 positive f of x. So not continuous. No. Okay. It's not continuous. Now let's go on to 2. Whether it's continuous at 2. Okay. Let's check the answer. I forgot that. Yeah. It's written no. Not continuous. Correct answer. Let's go on to the next one. Okay. Now at x equal to 2 we need to check. So let's start checking at x equal to 2. Students, start checking. So what is it? LHL, left hand limit, okay, is limit of x tends to 2 negative, okay, f of x is equal to limit of x tends to 2 negative. Now what are you going to use? Look, now when you draw the graph, okay, now when you draw the graph, we are talking about the point 2. Okay, we are talking about the point 2. The graph is approaching like this kind towards the point 2. So you can see somewhere over here we are checking approaching from the negative side. Okay, so approaching from not from the negative side, from the negative direction. Okay, approaching from the negative side, right? But if it's coming over here, if it's approaching from the negative side, now it's gone to the positive side. So you can see that even if it's less than 2, it's probably 1.5, but it's greater than 1. So we have to use this function, greater than 1, 5. Look, the point over here, somewhere over here, it's 1.5, okay? And 1.5 is greater than 1. So we use 5 over here. So that is the answer, 5. Now let's go on to the RHL, the right hand limit. So limit of x tends to 2 positive, f of x is equal to limit of x tends to 2 positive. Now look again, what do we have to use? Now we are approaching the graph, we are approaching this. The graph is approaching, not we are approaching, this approaching from the positive side. So somewhere over here, then definitely that's greater than 2, say 2.2 or something like that. Then 2.2 is greater than 1, because we have to keep looking at the function. Okay, greater than 1 we have to use this, not less than 1. We cannot use x. So 5, so again we got a 5. Then f of, next is f of 2. Okay, f of 2. So when you put 2 in the function, what are you going to use? Which value? This or this? Of course, 2 is greater than 1. So it's going to be 5. So again you got a 5. So what did you get? Limit of x tends to 2 negative, f of x is equal to limit of x tends to 2 positive, f of x is equal to f of 2, which is equal to 5. Okay. So what do you have to write? Yes, it is continuous. So in the first part we got a yes, second part we got a no, and third part we got a yes. So there is a break in the graph. Okay, there is a break in the graph at x equal to 1. Again the graph is continuous from x equal to 2. Okay, so that's it students for today. This is the second part of your video. I will continue the third part and the fourth part in the next time. That's it for today. So keep taking as much help as possible from my and your channel. Math is possible. See you in the next video. Bye bye.